Let's talk about area between two curves. So you can see there is a one curve already, like a parabola, and we can have another line or another curve. So this is area under this curve, the blue one. For example, we don't want to take the full area. So if you just want to take from 0 to this value, okay, so that will be the required area. We will eliminate this area. Now here is another line. Actually, if this curve is divided by this line, so of course the area will be divided into two parts. One is above the line and second is below this line. So this is the area which is below the line, like a triangle. So basically we could say this is the upper curve and this is the upper area. This is the line x equals to a, for example, from 0 to a. That area is deleted. Now this is area under the curve between 0 to a. Okay. Now let's take the line. This is the line. Okay. So if you concentrate on this, this is called lower area of the line, under the line. And what is the required area for us? So this is the area between curve and line. You see this blue one, the whole area minus the area under the line. Okay, so that's how we need to figure out area between two curves. Area under upper curve, subtract or minus area under the lower curve. So using integration, we will use from 0 to a of fx of upper curve minus 0 to a from the same limit f of x of the lower curve. Remember, these points are very important because these are the points of intersection of curve and a line, or maybe two curves. Let's take the real examples. For example, we have find the area enclosed by the curve y equals to x squared plus 1. It's a parabola, and the line y equals to 5. So have a look. The first step, you must have the sketch of these two curves. So do the sketch first. You can see this is the parabola, and here's the line y equals to 5, y equals to 5 units above x-axis. And this is the area between two curves, maybe one curve and a line. Okay. So first, we would like to have p and q values, the x coordinates, because we are taking limits on x-axis. So that these are actually points of intersection. So let's figure out points of intersection, because both are equating with y and y. So we can substitute 5 into x squared plus 1, which will give you two values of x. Here you go, x squared equals to 4 plus minus 2. So the coordinates are minus 2, 5, 2 and 5. Of course, we don't need 5 and 5. We just need minus 2 and 2. So here is minus 2 and here is plus 2. So maybe you can draw these lines also to say where are minus 2. See, this is minus 2 and this is also plus 2. So guys, this is the area under the line. Okay, and we call it area A. It's like a rectangle. So even you don't need to integrate this. Even if you integrate, no problem. And this is the area B, which is only under the parabola. But if you remember, we are talking about area enclosed by the curves. So enclosed means the area bounded by two curves. One is parabola and one is line. So you see the area under the line is bigger than area of under the parabola. So we'll take upper as line and lower as the parabola. So we subtract the area under the line minus and this area under the parabola. We have limits. So to get the area, we will subtract area A and area B. So let's find area A first, or maybe you can work together. It's a rectangle, I told you, no need to apply integration. Now area B. This is actually integration of parabola from minus 2 to 2. So minus 2 to 2x squared plus 1 dx. So here you go, you integrate using power rule and apply the limits, and you get some 9 is to 2 by 3. It's approximately 9 square units. It's the answer is not clear here, don't worry, you can work out. So the area 20 and 9 is to 1 by 3 we need to subtract. That's the required area. So you can work out this is 10 is to 2 by 3. So let's take another example. You can maybe pause this video and reverse it to see what we have done. So another example, now we have another parabola. This is downward parabola because minus x square means downward. X plus 5, it's a diagonal line, maybe 5 units above the x-axis. So first try to sketch if you know, and this is the line. So this is the required area what we need, okay, this red area. But you need to see which is the upper curve and which is the lower curve, and then points of intersection. So find the point of intersection first. You know both are representing y's, so we need to work out these 2 points. So here you go, you equate both y's together. So take x on one side, so it's actually a quadratic equation. Factorize and solve. Maybe you will get 2 answers, one is positive and negative. So negative 2 and 1. So negative 2 is here and 1 is here, okay. So to find the area, what we need to work out area from minus 2 to 1 under the parabola and then under the line. So we will see this is the parabola upper and the line is the lower. So upper minus lower, always remember. So area under parabola and then area under the line, and then subtract. So here you apply the integration, minus 2 to 1, 7 minus x squared and minus 2 to 1 of x plus 5, because it's a line, lower curve. This is upper curve. So we can even subtract before integration. Now you got a simple expression here. You integrate it and the area required is this. Don't worry about this. Even you can separate, integrate and then you subtract. It will give you same area. So you need to apply the limits after integrating. We are just using power rule of integration. Be careful about the fractions, please. So I got 4.5 square units. So that is the area. Thank you.